Hi, it's Liz Snedden. This is my model answer for the assessment task for AS1.1. So this is an example of a video recording that a student might do. So here is our brainstorm. So the first thing that we needed to do was do a brainstorm and figure out what we wanted to do. So here's our brainstorm looking into what identity is. And from within that, our group decided we were going to focus on the family aspect of it. And in terms of our group, there's me, Hannah, Jess and Jim that are going to work together on this project. We then needed to decide what our variables were, and so I needed two categorical, two numeric variables. So our categorical variables were going to be about the number of, whether we have what our gender is, male or female, and the second categorical variable is about whether or not you have a blended family. Then our numeric variables, we were going to count the number of siblings that we have and the number of cousins that we have. Then we needed to define what is our population, and so our population is going to be everybody in our school, or the akonga in our school. Our sample, so the ones that we are going to focus on, we are focusing on the akonga in our classroom, and they are a mixture of ethnicities, different genders, different family types, etc. And we've basically taken a cluster sample, so a random sample. So our plan. Well, our plan involved thinking about what are some of the things we needed to control. And so some of the sources of variation that we had, one of them was to think about, well, what does it mean to be a sibling? And so does it include half brothers and sisters? Does it include adopted children in the family? Does it include whāngai or other people that live with us for a long period of time? So we decided that we were going to say a sibling is any child that is raised by either parent. So that includes half siblings, it includes anything else like that. And because we're including everybody that the parent raises as a child, that number will be larger than if we didn't include everybody. Another source of variation we had to control was making sure that everyone knew what a blended whānau, blended family is. And so we needed to think about, does that include people that are not married but are in a relationship? Does that count as a blended whānau or blended family? Do they both have to have children of their own? Do they have to have children together? What does count? And so we decided it was going to count when one or both of the parents have formed a new relationship and one of those partners has a child. And it could be that that's a child from a previous relationship, or it could be a child from the new relationship that they've had together. So then we created a survey, and our survey, I'll just open this, has a range of questions. So this is what we had here. We had 4 questions that we asked people to do, and we sent this out by email, and people, during class time, Kayako asked everyone to complete the form for us. Okay. Then we have our data that we collected. So if I load this up, this is our data. So this is the data that was entered, and we then cleaned that up, and I've put some new headings across the top there, and we've got 31 pieces of data in there. And that's our data that we are going to use. Okay. Let me just get that tidy back up again. Sorry. Okay, did that. Then we started, once we collected our data, then we can analyze our data. So this is our first graph, and this is a graph looking at gender. And so what we found is that we can see with this grid plot here, the number of orange squares, which are our males, are the same as the number of green squares, which are the females. So as you can see there, 48.39% male and female, 15 people in each group, and there was one person who preferred not to say what gender they identified with. So that's what we had to start with. I then filtered by gender and removed the person who preferred not to say so that I could do some comparisons. So that's what I've got on the next graphs. So here is a graph of looking at the female students and the male students and looking at how many siblings they have. So on the axis up there I've got my number of siblings. So we can see there we've got a median of, for the females, of 4 and the males of 5, and so those medians are actually quite close together. So the females have got one less median, their median is one lower sibling than the males, but they're actually quite close together. If I think about the shape, so if I was to draw a shape over the top of that, it looks, for the females, would be roughly normal, and the males, again, it goes up and then it comes down, so maybe a bit right skewed or normal distribution. And they are both unimodal, one main peak in the middle, one hill in the middle, and a bit of variation going on there. So if I've calculated my interquartile range, I could say there's my interquartile range. 5.5 minus 2.5 for the females would give me an interquartile range of 3. The males would have an interquartile range of 2.5. And I can see how wide this box here is compared to how wide that box there is. And they're roughly similar. So the variation in that middle 50% of males and females in terms of number of siblings is pretty similar. Okay, so now I've got a triangular graph here looking at cousins. So looking at the males and the females. So the females are the orange ones on top and the males are the green ones underneath. And so if I look at the shape of that distribution for both of them, they're both a right skewed distribution. So there's a bulk of the data that's down here, and then there's a longer tail going up. So there's a few people that have got lots and lots of cousins, but the bulk of them are around about here. And we can see the females have got a median of about 15 cousins, and the males median of 17 cousins. So again, quite similar in numbers. A little bit of a difference. The males are a little bit bigger by 2. But very close. Then I can look at the spread, so the interquartile range. So the females 20, take away 11 will give me an interquartile range of 9, and the males 21 minus 13 gives me an interquartile range of 8. And so I can see there the variation of those is fairly similar. 8 and 9, very, very similar variation. Then I look at, can I make an inference? And so what I've got now is I've just focused on the box plot of both of these. So I've got the first one here on the left that's looking at the distribution of siblings, comparing males and females. And I can see the median of both of those boxes are inside each other's box. So if I draw that median of the males down, it goes into the females box. And the females one, if I draw that up, it hits right on the lower quartile there of the males. So that tells me I can't make the call. So I can't say that for students in our school, so extending this to the population, that our Congo in our school, we can't say that we have enough evidence that there tends to be a difference in the number of siblings that girls and boys have. And the same thing for the cousins. The medians of both of those fall in each other's boxes, so I can't make the call that there tends to be any difference in the number of cousins that males and females have. And if I think about the reasons for that, so kind of telling the story, what we need to think about is that boys and girls there's a 50-50 chance that a woman has a boy or a girl baby. And so because that's 50-50 split, an even split, I wouldn't expect girls or boys to have more or less siblings. I'd expect overall there'd be quite similar numbers. And that's what we can see there, both in terms of the number of siblings and the number of cousins, that there isn't much difference between the girls and the boys in terms of how many siblings and cousins they have. It's just there is some random element of whether a woman has a girl or a boy baby. And the last thing is this idea of sampling variability. And I've just borrowed this animation from Professor Chris Wild at the University of Auckland, just to give us an idea of what sampling variability is. And if I apply it to the situation that we've investigating our class, I can say that every sample we took in another class, we should get similar-ish data. You can see the blue dots, they change every time. So the number of siblings and the number of cousins would change every time we took another sample. But the medians will move around a little bit, and if I take the median for my sample and we compare it with another sample of students at our school, I would expect that they would have similar-ish medians in terms of the median number of siblings and cousins that we have. And further, I expect my conclusion that I can't make the call to be the same no matter which sample I take, because the idea that boys and girls, there's a 50-50 split in the population, I would expect that to be true for any class that we sample at our school.